Hello everyone, I'm Adam. In this problem, for a function given as f of x equal to 2x minus 3, we're going to try and find any absolute extrema, if any exist, over our four intervals. We have the closed interval from 0 to 2, so our half-open interval, closed at 0 and open at 2, our half-open interval, open at 0 and closed at 2, and the open interval from 0 to 2 here. So to start with, what we're going to do is start by trying to find any, say, critical numbers. All right, so critical numbers, and specifically on, say, the open interval from 0 to 2. Since all of these intervals essentially have the same endpoints, right? Finding the critical numbers here is essentially going to find us all the candidate points, the x values in the middle of all of these intervals where we might have absolute maxes and mins. Okay, so since it applies to all of them, we'll just go ahead and find it first. So the critical numbers, right? Well, we start by taking our derivative. So f of x is 2x minus 3, so f prime of x is just equal to 2. And so critical numbers are the x values wherever the derivative is 0 or undefined. And so looking at what we have, well, our derivative is not going to be undefined. Looking at the value 2, but we know that also, since what we start with, well, 2x minus 3 is a line, but essentially it's a polynomial. And you know, whenever you take the derivative of a polynomial, you get a polynomial back, and a polynomial is defined everywhere. So that's why we don't have to worry where the derivative is undefined, just where it's equal to 0, but our derivative is just the constant 2, and so 2 is never equal to 0. So what that tells us, as far as the critical numbers are concerned, essentially, we're not going to have any. Okay, so now let's go ahead and take a look more specifically at our intervals. So for part A, so we have the closed interval, say from 0 to 2. So the steps for finding an absolute maximum over a closed interval is first you look at your critical numbers, which we found we don't have any. Then, or if we did have critical numbers, we'd find the y values at there, and then we'd look at the y values at the endpoints and then compare them. So since we have no critical numbers, we'll just jump into looking at the y values of our endpoints. So back into our original function, f, we're going to look at f of 0, right, which is going to be, what, 2 times 0 minus 3, or negative 3, and f of 2, right, 2 times 2 minus 3, right, or a positive 1. And so taking those, the overall smallest value that we have, which here at negative 3 is our absolute minimum, and the largest value at 1 would be our absolute maximum. So we can say at x equals 0, we have an absolute minimum, negative 3, and at x equals 2, we have here an absolute maximum of positive 1, right, over our closed interval from 0 to 2. All right, so let's take a look at the next interval. So our next interval is closed at 0 and open at 2. Now, since we have the same function, right, and basically the same interval, just the fact that we're not including 2, right, everything we just did still holds. We don't have any critical numbers, so there's no candidate points on the inside for where we'd have absolute maxes or mins. So we can kind of get right away that, again, at x equals 0, we're going to have, say, an absolute minimum, right, at negative 3. But now, since we're not including 2, would we still have an absolute maximum? Well, in this case, no, we're not going to have an absolute maximum. Now, why is that? Well, because as we continuously take x values closer and closer to 2, right, the y values are going to get bigger and bigger and bigger, right? But since 2 is not included, we can continuously take x values closer to 2, which means we can get y values bigger than the one that came before it. And so there's no one y value for an x value inside this interval that's going to be bigger than everything else. So in this case, we would have no absolute, say, maximum. Okay, and let's look at part C, so interval where we're open at 0 and closed at 2. Okay. So by the same argument, right, is what we just looked at for part B. We're not including 0, right? So I can take x values as close as I want to 0, but never equal to 0, which means I can get y values corresponding smaller and smaller and smaller, but no one y value that's going to be smaller than everything else. So in this case, we would have no absolute, say, minimum, right? But we are including 2, so at x equals 2, we again have an absolute, right, say, maximum of, well, we get positive 1. And so last but not least, part D, so we have the open interval from 0 to 2. Okay? Now here we're not including 0 or 2, right? So putting it all together, we don't have any critical numbers, so no candidate points in between. We're not including the endpoints. So here we actually wouldn't have anything. So we'd have no absolute minimum and no absolute maximum. There we go. Thank you very much.